Alright, this is a quick video on how to deal with complex numbers in your denominator. We don't like to have denominators with complex numbers in them. This one clearly does because of that 4i. So 3 plus 4i is the complex number. It's in the denominator. We don't want it. I's represent the square root of -1, and we don't like radicals in the denominator. So to get rid of those, we have to use what's called the complex conjugate. Complex conjugates have this form. If this is your complex number, then its conjugate is a minus bi. Okay? So they always have this differing sign right there between the real part and the imaginary part. So in the problem that we have on the left here, if I want to get rid of the conjugate, or the 4i in the bottom, I have to multiply the entire denominator by the conjugate of that denominator, 3 minus 4i. Now I do the same thing to the top, so what I'm doing is really multiplying by a giant 1 here. Think about that for a second. This fraction, because the numerator and denominator are exactly the same, this thing is just a giant 1. Okay? And so I'm changing the way this fraction looks, but I won't actually be changing the value of the fraction. So let's go ahead and do the multiplication now. In the numerator, it's a big FOIL problem if you want to think of it that way, but we're distributing. So that 5 gets distributed, and then we distribute the 2i. So distributing the 5, I get 15 minus 20i, and then distributing the 2i, I get 6i, and I get minus 8i squared. In the denominator, this is where I want some magic to happen. I want to get rid of the imaginary numbers. And I just let the math do what it's going to do. I distribute the 3, and I get 9 minus 12i. And then I distribute the 4i, and I get positive 12i minus 16i squared. Now, let's wrap up while we're in the denominator, let's look at what's happening. You can see by using the conjugate of the denominator in my multiplication, I get negative 12i and positive 12i, and they cancel each other out. So the denominator just becomes 9, and this negative 16i, remember I squared equals negative 1, so it becomes a plus 16 right there. Okay, so negative 16 times negative 1 is positive 16. The numerator, I don't get that canceling. Those two in the top, these two things in the numerator, those are not conjugates, so I don't get this canceling like I had in the denominator. I get negative 20i and 6i, it's negative 14i, and there's that I squared, it's negative 1 again, so I get a plus 8 there, negative 8 times negative 1. So I simplify the old numerator there. Let's grab a different color here. I got 15 is real, 8 is real, so that's 23 minus 14i, and my denominator just becomes 25. And so this would work for a solution, or if I want to separate the real part, I put 23 over 25, I put minus 14i over 25. So now there's my real part, and my imaginary part is negative 14/25. So there's the real, and there's the imaginary portion. This over here would be a perfectly acceptable answer, but just be prepared to break it up into real and complex parts if you're asked to.